Triple integrals in spherical coordinates. The objective is evaluate the triple integral by changing to spherical coordinates. Already we have learned how to convert double integral in rectangular coordinates into double integral in polar coordinates. Similar situation occurs when we consider triple integrals involving spherical symmetricity. In this class, we convert triple integrals in rectangular coordinates into triple integrals in spherical coordinates. First, let's proceed with the definition of spherical coordinates. In three-dimensional space, we specify a point P in the spherical coordinate system by rho, distance from the origin to the point P, theta, the polar angle from the positive x-axis, phi, the angle from the positive z-axis, and the line OP. We note that rho positive and will be 0 only when point falls to the origin, and phi will be 0 to pi. When phi 0 point falls to the z-axis positive direction, when phi equals to pi, the point falls to the z-axis negative direction. Spherical coordinates will be useful to calculate triple integrals over the regions which are symmetric with respect to origin. Using the definition of the trigonometric functions, we can easily obtain relation between spherical coordinates and the rectangular coordinates of the point. Let rectangular coordinates are x, y, z, and spherical coordinates are rho, theta, phi. And as we said, rho is the distance from the origin to the point P, and the phi angle between OP line and the positive direction of the z-axis. Theta is polar angle. So if we do projection of the point P to the xy plane, then we can measure the theta using the polar coordinates. Example, convert the point P with the coordinates 3 pi over 3 pi over 2 from spherical coordinates to rectangular. So here rho is 3, theta is pi over 3, and phi is pi over 2. Just we replace in the formula we just mentioned rho, phi, theta by their values, which is given in the problem. And by calculation, we obtain that x values will be 3 sine pi over 2 cosine pi over 3, which will be 3, 1, 1 over 2, 3 by 2. And similarly, we can calculate values of the y by substitution of the rho and phi and theta values into the formula, which gives the result 3 times root of 3 by 2. And z value will be 3 times cosine pi over 2. Cosine pi over 2 is 0, so z will be 0. By such way, we obtain the value of the point P in the rectangular coordinates. If we want to convert the point from rectangular to spherical, we need to little bit modify the formula we just mentioned above. For this, what we do, the values of the x, y, z will replace with their values in the spherical coordinates. And in the first two terms, we can factor out the common factor from the brackets. And inside of the bracket, we get the function which is equal to the 1. We use the trigonometric identity. Then in the rest, again, we factor out rho square from the terms, and the remaining terms equal to 1, so we got rho square. So we are getting first formula which connects x, y, z with the rho, and another one, if we divide y by x, Then rho sine phi's are cancelled, and we got the tangent theta equals to y by x. If we divide z by rho, rho cancel, we got the cosine phi. By such simple calculations, we arrive to the following formulas. Okay, first we can see the formula which we have just obtained from the representation of the point in the spherical coordinates. In the second line, you can see the three formulas we just derived from them. The first three formulas will be convenient to use when we want to convert the point from spherical to rectangular coordinates. Second line three formulas will be useful to convert the point from the rectangular to the spherical coordinates. Let me finish this part 1 with the following problem. Convert the point P from the rectangular to the spherical coordinates. Okay, we write down the formula which we just derived, and we replace x, y, z with their values, 3, 3, 3 root of 6, and tangent theta also we can find, which is 3 by 3, and cosine phi will be just z by rho. Rho is, we can just calculate 72, root of 72. Okay, we substitute and do simplification and cancel the similar factors. Then we got the following value for cosine phi, and for tangent we got 1, tangent theta equals to 1, and cosine phi equals to that number, root of 3 divided by 2. And using the calculator, you can easily find the values of the theta and phi. So rho is root of 72, theta is pi over 4, and phi is pi over 6. Okay, by this way we derive the point in the spherical coordinates. Okay, this completes our part 1 of the triple integrals in spherical coordinates.